Welcome to another video of secondary chemistry. Our today's topic is states of matter. And in science we distinguish between three states of matter, and these are solid, liquid and gas. Probably we are most familiar with the different states of matter regarding the substance of water. We know solid water, which has a special name called ice, and we know liquid water that has no special name, it's just called water. And we know gaseous water called water vapor and sometimes steam. What is interesting now to note is that the three different states of matter are not characterized by different particles. There's not something like ice particles, water particles, steam particles. It's all water particles, but what makes the three different states of matter distinctive is the arrangement of particles within a certain state of matter. So we can conclude that the states of matter are not characterized by the type of particle, but by the arrangement of particles and some more things that we will be talking about in the end of this video. So when do we call something solid, liquid or gaseous? This question is not as easy as one could think. If we look at the picture of oil here on the top left-hand corner, we all can see that oil is a liquid. We could instantly tell. As well, we could instantly tell that steel is a solid. But why do we know that oil is liquid and steel is a solid? Sometimes we have like our daily life experience and we have it in our feeling which state of matter a certain substance is in. But as scientists, this is not enough for us. We cannot rely on our feeling, but we need to have objective criteria to tell whether a substance is a solid or a liquid or a gas. And that's why we'll dive in a little bit deeper into this topic now. One thing that can help us to separate between the different states of matter is the fixed volume. And fixed volume means that the volume of a substance cannot be changed even if we, for instance, increase the pressure from outside. Volume is the space that matter takes up. And if we push on a substance and it changes its volume, it does not have a fixed volume. But if we push on a substance and it does not affect the volume, then this substance has got a fixed volume. Now, if we look at solids, we can see or check whether they have a fixed volume. Here you can see myself with a gas syringe, and I have put a piece of wood into the gas syringe as a representative of a solid. I'm trying to compress it to change the volume of the piece of wood, but obviously I'm not able to do it. That's why we can tell that solids, yes, they have a fixed volume. I cannot change the volume by increasing the pressure. If we look at a liquid, we can note maybe something else, maybe the same thing. That's why we carry out the experiment. And first of all, we fill some water into the gas syringe. I'm using tap water here from the science lab. And when I have filled the syringe with enough water, I remove the pipe and also push out the air inside the syringe, because air is a gas and we just ought to have liquid in the syringe. Now I'm pressing on the water and try to squeeze it into a smaller volume. And again, you can see that the volume doesn't change, and therefore also liquids exemplified by tap water have they have a fixed volume, sorry. Gases behave differently, as we will see now. Here the gas syringe is filled with some air and the syringe is closed by my finger, and when I put in pressure from outside, you can see that the volume actually decreases. It is not fixed, and therefore gases have no fixed volume. Now we can see that if a substance shows no fixed volume, we can instantly tell that this substance must be in the gaseous state of matter. But if another substance has got a fixed volume, we can't scientifically tell whether it's a solid or a liquid. It could be both. That's why we need another point to clearly show whether a substance is a solid, a liquid, or a gas. And this other property where solids and liquids will differ, as we will see in a moment, is the point of taking the container shape. Taking the container shape means that the substance shape of any substance adjusts to the container shape, and this is nothing else than the ability to flow. Let's look at the solids again in the beginning. Here I'm using a metallic ball and I'm placing it into a round bottom flask, but the metallic ball, of course, keeps its shape. It has a definite shape, and the metallic ball remains a metallic ball no matter whether I store it in a conical flask, in a beaker, in a container with edges or which is round. It doesn't matter. And that's why we can tell that solids do not take the shape of their container, yet they still have a fixed volume. What about liquids? Here I'm using colored water, the red water, and it's something you also know from your daily life experience. If you pour water from one container into the other, the water will actually take the shape of its container. It adjusts, and this is because it can flow. But as you can see here in the round bottom flask, the water has the shape of a round bottom flask. But if the water is poured now into the conical flask, it changes the shape and adjusts the shape to the shape of the conical flask. That's why we can say that liquids take the shape of their container, still keeping in mind that liquids also have a fixed volume. If we look at gases, it gets a little bit more difficult because most gases are invisible, but we can imagine air, which is gaseous, being in the round bottom flask, and we could pour it into the conical flask, telling us that gases do take the shape of their container, because gases like air, they just indwell every given room, they take up any space given to them. And now if we look at this sort of table at the bottom, we see that with fixed volume and container shape, we have laid the foundation to identify every state of matter clearly. A substance which has a fixed volume but does not take the shape of the container must be in the solid state of matter. A substance which has both a fixed volume and the ability to flow, respectively taking the container shape, must be a liquid. And a substance is in the gaseous state of matter if it has no fixed volume but does take the shape of the container. Now we have scientifically made clear how the states of matter differ one from another. Again, you can see the table of fixed volume and container shape, and this table helps us now to create an idea how the particles of a certain substance are arranged in a certain state of matter. And maybe it's the easiest to first look at gases, because we have noted that gases do not have a fixed volume, unlike liquids and solids. And the reason for this is the huge distances between gas particles. As you can see, between gas particles we have huge gaps that are not existing in the liquid and solid state of matter. And that's why if we create an outward pressure on a gas, we can make the gas particles move closer together and thus decrease the volume of a gas. This is not possible with a solid and a liquid because there's not really space between the particles to squeeze them into a smaller volume. Regarding the container shape, solids are the only class of substance, so to say, which do not take the container shape, and that's why particles within a solid are packed very tightly and closely together, even a little bit more closer than particles within a liquid if you have a closer look. And that's why, because the particles attract each other so strongly, a solid will keep or have its definite shape, which is independent from the type of container it is stored in. Whereas liquids, or within liquids, the particles, because they are a little bit separated compared to the solids, they have the ability to move past one another and to slide over one another, and therefore to adjust to the container shape. So the particles within a liquid, they can flow. Now, what you should remember is FAME, because FAME will help you to know everything you have to know about the 3 different states of matter for GCSE and IGCSE chemistry. And FAME is a word where all the letters represent a property that has to do with the description of a state of matter. For example, the F corresponds to the property of forces. We can look at forces within solids, liquids, and gases. And within the solid, the attraction forces between the particles are very strong. We can imagine this being similar to the attraction forces between magnets. If you have the north pole of a magnet and the south pole of another magnet, then the magnets will attract each other, and the attraction force will be stronger the closer the magnets are to each other. If you increase the distance between the magnets, then the attraction force between the magnets gets less and decreases. And because in a solid the particles are packed so tightly together and are so near to each other, they couldn't be nearer, the attraction forces between the particles are very strong. Within a liquid, the attraction forces are still strong, but not as strong as in a solid anymore, because the distances between the particles have increased a little bit. But within gases, the attraction forces are very weak because the distances between the particles have become very big. Let's now talk about arrangement. Within a solid, particles are arranged regularly, and we call this arrangement a lattice. A lattice is like particles being arranged on horizontal and vertical lines, sort of. Of course, there are no lines within the solid, but we could imagine lines being there and the particles being located on these horizontal and vertical lines. Within a liquid, we have an irregular arrangement, which could be referred to as chain-like, but it's not as well structured as within a solid. And in a gas, the arrangement of particles is irregular. The particles are randomly spread out. What about motion? If you have watched our video about Brownian motion, you know that particles are in constant motion, and there are no particles which are not moving. Even within a solid, where every particle has got its specific place within the lattice, the particles are at least vibrating at the spot. In a liquid, as mentioned earlier, the particles are able to slide past one another and therefore take up the shape of their containers, so particles are free to move within a liquid. This is not possible for particles in a solid. In a gas, the particles, they move around freely without being influenced by any other particles. So yeah, they're simply moving freely. What about energy? Energy has to do with motion, because if you have to run to get the bus, more energy is involved than you slowly moving from one classroom to another and just, being on the move very slowly. That means the faster you travel, the more energy is involved, and the same is true for particles. So as particles in the gas move freely and fast and a lot, there is a lot of energy involved, so that's why energy is high. But in a solid, the particles are just vibrating. This is little movement and therefore also low energy. And within the liquid, we are somewhere in between, so we could say we have medium energy here. That's all for this video. Thank you guys for watching and see you in the next video.